everybody. Let's do some group work, shall we? So here is section 9.7, areas of similar figures. So we did almost all of this section for homework, and we even did some review problems before you started the homework in the last video lesson. So in this video lesson, I've just picked 3 problems that are actually on the homework tonight. So you're welcome to skip ahead to where I tell you about what the homework problems are, and maybe give the problems a shot right now if you want. If you want to try to do the homework and then go back and watch the video, if you got stuck on some problems, and then once you watch the video, try the problems you didn't get, and maybe you understand how to do them now. Okay, so usually we just do a little bit of group work in class for the second day of this section, so we're just going to do some group work now. Let's do it. Here's our first question. I had to look at this one for a good 2 minutes in silence to get all 4 of these. So maybe you can do that too. I'll start by giving you some hints. It helps to mark up angles. So I'm going to mark that up. And boom, I think we found our first pair of triangles. Triangle G, C, E, similar to triangle G, A, B. And this would be in a 10 to, we don't know this yet. We don't know what the ratio would be. I like this problem. So we need to come back to that later. Next up, we have triangle. Let's see if we can figure out another triangle. Well, very similarly, we have a vertical angle here, a vertical angle here, and this is a parallelogram, so I can mark this and this as congruent to each other. So these triangles here, ADC and CBA, are similar by AA as well. Does that help us to get the ratio of areas? Well, let's see here. We don't know this side length. We don't know that side length. We don't know any of the sides of these triangles. Well, we know that this is 6. Oh, we know that this is 6 too. That could help us because it's a parallelogram. Nice. Beyond that, we do know this top one here. Okay. So I'm going to go back to this top one here. Triangle GAB right here, and GCE down below. We do know their scale factor because this corresponding side down here would be 10. So EC or CE corresponds to AB, and this would be in a 10 to 6 ratio. Or if I were to simplify that, 5 to 3. Triangle ADC, does that help us with that? Let's take a look. Well, AB is part of a side of CBA, and that corresponds to DC. So this would be a 6 to 6 ratio. So these would just be 1 to 1. Okay, so you should probably know that by now, that if you have a parallelogram and you draw in a diagonal, it creates 2 congruent triangles. And if they're congruent, they get similarity for free. And then similarity within a 1 to 1 ratio. So similarity, it has all the side lengths are in proportion, but they're in the 1 to 1 proportion, and all the angles are the same, so they're congruent. All right, so that is 2. The other ones are a little bit harder to do, and I'm going to actually maybe highlight something to maybe make something jump out to you. Part of just going over this problem is just to highlight how hard it is to find this stuff. Again, it took me 2 minutes of sitting here being like, I need to find everything. Okay, I'm going to be persistent, I'm going to persevere, and one of the frustrating things I think about geometry is like sometimes people see it, sometimes you just don't see it. And don't give up. Hearing the explanation is worth almost as much as just doing the problem on your own. Okay, so I shaded that in. Where does this come into play? How does this become familiar? Well, this actually DF is part of side AD of the parallelogram. So we know that it's going to be parallel to this down here, to BC. And so here, this is kind of a reminder of the basic proportionality theorem, where if you have a parallel to the third side of a triangle, the side that the parallel does not actually touch with the triangle, it's going to form similar triangles, and it'll be in proportion. So here, ED to this 10 here, this ED is 4/10 of the side length of ECB. So let's write it down first. We have triangle ECB. We'll do the big one. Triangle ECB is similar to triangle EDF. And this would be in a 10:4 ratio. So that would be a 5:2 ratio. So that's neat because it allows us another thing, which may come in handy for the very last one. I'm not sure if it will or not, but we can actually extrapolate this over here to figure out what BC would equal. So this is in a 4:10 ratio, and this is 2. So if this is 2, this is going to have to be 5 down here. In a 2 for the little triangle to 5 for the larger triangle, or 5 for the larger triangle to 2 for the smaller triangle. 10:4 is the same as 5:2. And you could have set up a proportion to figure that out through cross multiplication, but you could also just reason through it in your head. Hopefully you see that. Last one. Let's see if we can figure out the last one. Well, I figured it out already, and now I'm kind of blanking just looking at this. What haven't we talked about yet? Ooh, I see it. I think we see it. So maybe you thought, since I have the 2 there, I have the 5 there. I'm going to fill this in as 3, because this is going to get us to the final triangle that's going to be similar. And we talked about ADC being similar to CBA, but there's another thing that's going to be similar to, well, not CBA, but CBG. This vertical angle right here, vertical angles are congruent, so that's a good sign. We just need to get one more angle being congruent. Oh, we already have this angle being congruent. GAF is congruent to GCB. And that's going to be our fourth and final congruence. Triangle GAF is similar to triangle GCB by AA. And that would be in a 3:5 ratio. Okay, wait, did I do this correctly? Let's make sure I solved this problem correctly. What's the deal with these? What are these here? So I was so hung up on what the 4 similarities were right here that what I shared with you guys wasn't actually this, the ratio of the areas, okay, the ratio of the areas. What I showed you was the perimeter ratios. So that's not what the question was asking. So I'm hoping you went one step further and you squared everything. And here we have it. We have the ratio of areas. So even though our triangle is only 5 to 3 times bigger in terms of perimeter here, your area is way bigger of this triangle. This is a 25:9 ratio. Still a 1-to-1 ratio with triangle ADC to triangle CBA, because they're actually congruent in addition to being similar. So that doesn't change at all. But triangle ECB to triangle EDF, they would be in a 25:4 area ratio. So make sure you didn't do what I did originally and get the perimeter ratios or the scale factor. You got the area ratio. So one kind of tricky thing, and a lot of times why, if you're going real fast on a standardized test, you might not have to reread the question to make sure you answered it correctly. So there's number 1. And let's move onward, okay? Let's try number 2. Let me check this one out. All right, I haven't done this one yet either. So we have number 18, group work number 2. Are figures 1 and 2 similar? Name 2 similar triangles. What's the ratio of the areas? And what's the ratio of the areas of figures 1 and 2? All right, this one looks a little more straightforward. Ready, set, go, do it. You got this one. This isn't quite as hard. And let's review it. They both share angle A in common, and then these 2 angles would be congruent. So AA, similarity. So yes. What's the ratio of their areas? Well, this would be a 2 side of AE, but AC would be side length of 5. So don't just take the two numbers and square them and find the ratio between the two, because you might have to do that additional step to find the length of AC. Triangle ADE is similar to triangle ABC. So CA's length is the one we care about. So the ratio of the areas are going to be 4 to 25. What's the ratio of the areas of figures 1 and 2? Ooh, that's interesting. Okay, so here's maybe where you think about this in terms of variables. I always get questions about this problem when we go over it for homework, so that's why I'm kind of getting ahead of it there. So the ratio of their areas, we can maybe introduce a variable to kind of make this 4 to 25 thing be true. So let's let the ratio of the top triangle to the large triangle, let's have that. So we got top triangle to the large triangle. Let's have that be a 4x to 25x ratio. So whatever the area is here, we would just need to multiply it by 25 and divide by 4 to get the area of the entire triangle. So if I label this here as 4x of the 25x area of the triangle area, I'll put here area, little a actually stands for area of the figure, so area of triangle ABC would equal 25x. Area of triangle ADE would be 4x. And I think you know maybe what mathematical calculation you would need to figure out what would have to represent this here. If the whole triangle is 25x and 4x of it is knocked out by region number 1, which is this triangle up here, what would region number 2 have to represent? Well, region number 2 would have to be 21x, because 4x plus 21x would be 25x. So if this were 4, this were 21, 4 to 21 ratio would enable a 4 to 25 ratio for the whole triangle. Okay, so what is the ratio of the areas of figures 1 and 2? Well, it would be 4 to 21. And there is our answer. Last question. Those were two ones that I always get questions about, by the way, when we go over this for homework. So don't worry if you saw it, you panicked. Hopefully you're not good at panicking right now. Hopefully you're good at trying something, trying different things, marking up the diagrams, persevering, doing it up, and you got this. Okay, last one here. I think I've assigned this one before, so let's give it a shot, see if we can get it. The area of a parallelogram, parallelogram ABCD is 48 square centimeters, and DE equals 2EC. Find the area of each triangle. All right, there's your diagram. Hopefully you're marking it up. Hopefully you're recopying it, because, hey, recopying and marking it up, good way to get unstuck on problems and persevere and work through it. Take a few minutes, ready, set, go, unpause, and we'll review together just afterwards. All right, I've just labeled up a few things here. I haven't actually finished the problem, but I think by labeling these things up, maybe you're coming up with an idea on how to tackle something like this. And again, I haven't done the whole problem. Let's see if it works out. So see what I've labeled up, see where you think, what you think I might be suggesting right here, and actually reread the problem. Reread the problem and think about maybe when I fill in the thing that you think I'm going to fill in next, how I would then, where I would go to solve this problem. Think about it a little bit longer, then we'll come back together. Okay, what I'm looking at here, we have parallelogram A, B, C, D. So I gave me these variables here. DE is twice as long as EC, so I made this 2x because that's twice as large as x. So I'm just assigning a variable. Let length of EC be represented as x, and let length of DE be 2x because it's twice as long as length of EC. So this would represent 2x plus x would be a variable representation because we don't know exactly how long DC is here, but a variable representation of how long one of the sides of the parallelogram is. So 2x plus x is 3x, and that would be length of DC. So that's going to tell us what length of AB is, because AB is congruent to DC, because opposite sides of a parallelogram are congruent. So the next step of this is to figure out what the area is, which is 48 centimeters squared, and how we can kind of solve for x, actually. So let's see if we can solve for x, or figure out what we do here. One thing that these three triangles have in common, I'm going to put them all in here. What do these three things have in common? Well, I haven't added the perpendicular yet. Through a point outside a line, I'll introduce a perpendicular to that line. These would all be congruent because these are parallel lines, because it's a parallelogram. So this is H here, this is H here, and this is H here. What this tells us is that these areas of these three things, these areas are going to be in the same ratio as this side length to that side length to that side length, because they all share the same height. Remember, the formula for the area of a triangle is 1/2 base times by height. So all of these, to figure out the area, let's just do one for example. This triangle ABE would be 1/2 H times by 3x. So that would be represent the area of ABE. Down here, it's going to be very similar to this because you'd have to do the 1/2 and then you have to times by H and then you have to times by 2x here. So the areas are going to also be in a 1 to 2 to 3 ratio. So I'm going to define another variable here to represent what the areas of the ratio, I'm going to define another variable here to represent what the areas of these could possibly represent. So let's choose y for this. So I'm going to write 3y here for this triangle. I'm going to write y here for this triangle, and I'm going to write here, I'm going to write 2y. These are not similar triangles, so we don't need to square the ratios of the side lengths to figure out the ratios of the areas, because the side lengths, only really one of the sides changed in kind of a consistent way. 1 to 2 to 3, they have the same altitudes, so they can't possibly be similar, so their areas will just change in that ratio. How does that help us solve this problem? Well, we know that the area of the parallelogram is 48 centimeters squared, and those three triangles combined represent the entire parallelogram. So we would know that 48 would be broken up into a 2-part section out of 6 parts total, right? There would be a 2-part section, that would be that triangle. 3y is just going to be half of the parallelogram. We're going to get that really quickly. So this triangle is going to be 24. And this last one here is going to be 1/6 of the triangle. So if we solve for y, that might be one way to solve it and then plug back in. This would be 5y, and then we'd have 6y. So 6y equals 48. Divide both sides by 6, and y equals 8. So triangle ECB, let's see if we're asked to find that. Yeah, there we go, ECB. This one here, let's change colors just for when we put the answers. And I want a nice color here. Let's go green. Our answer here is just going to be 8 for this guy. 8. And next one that we have here, ADE, this one's going to be 16. Last one here is the big guy. That one would be 3y, and y was 8, so it's going to be 24. All right, CEF and DEF. Here's the one that I haven't really pondered. I haven't really considered these ones yet. So I'm going to pause for a second, think about them, and see if we can complete this problem. All right, let's start with CEF. CEF has the same height as DEF. So these would be in a 1-to-2 ratio. All right, that idea didn't work out. I was thinking about this more. This is a good problem. This is definitely a presentation problem, and again, something that I don't expect everybody to see, and one of the frustrating things about geometry, but hey, it's also one of the exciting things about it. I think I understand now. Hopefully you get this. I'm going to label up a little bit differently. I'm going to label this, which is triangle CF. So I'm still going to start with that, but I'm also going to label this triangle right here. We already know this triangle. This is ADE. What do we know about ADE compared to CEF? They are similar triangles. So we're going to use that theorem about similar figures, and if their scale factor changes, what does that mean about the ratios of the areas? So we know that this angle DAB would have to be congruent to angle EFC. So they would correspond to one another because these are alternate interior angles and these are parallel lines because this is a parallelogram up here and CF is just an extension to this. Vertical angle right here, they are similar by AA. What else do we know about these two triangles? Well, looks like we have it here. This is an 2-to-1 ratio. So this here, because this is what we know already, we would have to go from here to down here, and in 2-to-1 perimeter ratio, their areas would be in a 4-to-1 ratio. Because remember, we'd have to square that. 2 squared is 4, and 1 squared is 1. They'd be in a 4-to-1 ratio. So triangle ADE, we would just have to divide that by 4. Divide by 4 to get us CEF. And CEF is going to be 4 area. Let's see here. Ooh, man, this is a tough problem. Now we got to get this one. How does this one connect? Pause the video for a second because I got to think about it for a second. You see it? I got it. This goes back to my original thought, which was that this height would represent technically, right, if I were to turn this into like a parallelogram type thing, say that introduce a parallel here, this height here would be the altitude going to this base, which is 2x length long in triangle DEF, compared to here, this would actually be the same altitude of this triangle going to this x length, EC. So here they share a height. There's a side length difference of 2-to-1. So that means that triangle DEF is going to be twice as large in terms of area than triangle ECF. So we're going to take our 4, we need to multiply that by 2, and that's going to give us 8 as our answer. Fun lesson for me today. That's it. I think that was just fun because I hadn't done those problems in a while, and it's even stuff that I have to think about right now. So give it a shot tonight for homework. You had number 15 there. 3 of those problems, numbers 17 to 24, we just did. So we've done 3 of those problems. So you're going to have 5 problems beyond that. So 6 problems on section 9-7 tonight, and 6 new problems, that is, that you haven't done yet. But make sure you know to do the ones we did in class today. And then self-test, page 414. That's self-test number 2, numbers 1 through 8 all. So that's the last self-test of the chapter. You did, as part of our optional assignments, before spring break, I assigned self-test number 1. So make sure you know how to do both those self-tests, because here we are at the end of the chapter, and you want to feel like you've accomplished everything you want to accomplish in this chapter. So give it a shot tonight, and thanks for joining in, and I will talk to you guys very, very soon. Bye.